topic 3, numerical descriptive techniques. Again, measures of central location, measures of variability, relative standing, and linear relationships. Maybe we will cover up to here today, and then the rest of the topic will be covered in the online lecture next week, hopefully. So measures of central location. The first thing is the arithmetic mean. Why we talk about central location? If you think about the sample or data, then data should have some kind of distributions. Like there are some kind of distributions, like how Korean people's height are distributed. So there are some large numbers and some small numbers. Like some people are short, some people are tall. But then naturally, what you may be mostly interested in is the middle point, right? So central location of this height distribution or weight distribution. Maybe Korean people's like average height is like maybe, I don't know, Korean man is like 175, and then Korean man's like weight is like, I don't know, 70 kilogram or something like this. So people are interested in those like a middle value. And the first candidate measure of central location is definitely the mean, or AKA also known as average. Some people use expected value as also mean, and that is the most popular and useful measure of central locations. And this mean is calculated, as we know, it's the sum of the observations divided by the number of observations. But let me put it more clearly here. Sum of the values of the observations, right? So it actually doesn't make sense to summing up the observations themselves. So summing up the values of the observations divided by the number of observations. That's gonna be the mean. Okay. And let me introduce a little bit of the notation to write down the mean. So when we refer to the number of observations in a population, then we use uppercase letter N, capital N. Okay. So number of observations in the population. So population, you can think about Korean people, and then there are a number of Korean people that we don't know, but there is such number, right? And that number, like 50 million people, then this 50 million is capital N. Okay? And we refer to the number of observations in a sample, then we use lowercase letter n, small n, right? Small n. Okay? And then the arithmetic mean for population, so population mean, or some people, I usually say population mean. Population mean is denoted with Greek letter mu. So this guy, mu, right? Greek letter mu. So this is in Korean. It's not mu, it's mu. And mu can be calculated by adding up all those like values xi. So here this xi is what? This xi. So for example, like x1 is first person in this Korean population's like height. Okay? And x2 is second person's height. Third person's height is x3, and we add up these numbers and divide by the number of observations in the population. By the way, observation, when I say observation here, observation is basically that unit. Right? Observation is the unit. In Korea, it's 관측치, right? 관측치, unit. So many economists or many statisticians use the term observation. The observation is basically unit. Okay, it could be individual, it could be a firm, it could be a household, and so on. Right? So number of observations and number of observations are in the denominator, right? And here the important thing is this population mean is unknown. This is unknown. We never know the Korean people's average height as you go to places and all over the Korea and ask people's height. Some people's height is changing. So you never know Korean people's average height. So mu is unknown. And when we use Greek letter mu, right? Greek letter. Why we use Greek letter? Because we don't know. When we don't know things, then we use this Greek letter. And Greek letter is the parameter. Okay, parameter is Greek letter mu. And this Greek letter mu is basically the counterpart of the M in alphabet. M is the mean. Means first character is M, right? Mean. So we use the Greek letter mu. That basically symbols for M, right? And then sample mean. We use X bar to denote sample mean. So X with the horizontal line on the top. And then X bar is summation I equals 1 to n xi. Again, we adding up those numbers in your sample. You have 10 people in your sample and their heights. And first person's height, second person's height, you add up those numbers and divide by your sample size, n. Okay? So capital N is a number of observations in the population, or we can call it population size, and small n is your sample size, number of observations in the sample, number of units in the sample, number of individuals in the sample. Okay? That's how we calculate the sample mean. Even though there is a formula in the population mean, you can never be able to, you cannot calculate this population mean. Sample mean, of course, once you draw the sample and you have a sample in your hand, then you can calculate the sample mean. Okay, this is basically could be known. Right? Sample mean is known. Mean is basically good for describing some measurement data. For example, heights or student scores, weights, BMIs, those kind of things. If you have those kind of variables, then mean is very easy and appropriate for calculating the central location of those variables. But the problem of this mean is basically it is seriously affected by extreme values called outliers. You want to calculate or you want to guess the population mean of US adult, and then you got a sample of 10 people, and then somehow by chance you got Elon Musk in your sample. Okay, then you have this billionaire or even more than trillionaire in your sample. Then the sample mean will be extremely large. For example, like their average wage. Actually, Elon Musk is not getting any wage, but maybe let's say income. Then Elon Musk's income is like, I don't know, $2 trillion or something like this. Then average income of that you calculate from the sample will be very large. So mean is seriously affected by these kind of outliers. So there are next candidates. The other one we can think about is a median. Okay, median is calculated by placing all the observations in order. So all the values of the observations we put it from the lowest to the largest, and then we pick the middle one. Then the middle one is the median. In Korean, there are many different translations in Korean. I think one is 중앙값, 중위수, 중위값. I don't know. 중위값, maybe 중위수. Something like this. Some people use 중앙값, some people use 중위수. Something like this. So median. So if our data is like this, 0, 7, 12, 5, 14, 8, 0, 9, 22, there are 9 observations, odd numbers, whole suit. Right? Then we sort them from bottom to the top, 0, 0, 5, 7, 8, 9, 12, 14, 12, 22. Then the middle one, the fifth one, there are 4 in the left and the other 4 in the right, around 8. So 8 should be the median. Okay. If we have 10 numbers now, in the next example, even numbers, 짝수 개가 있으면, we have even numbers. Then we also sort them bottom to the top, 0, 0, 5, 7, 8, 9, 12, 14, 22, 33. Then the problem is there's not exactly the middle one. Then you pick those middle two and add them up and divide by 2. So 8 and 9, you add them up. So you got 17, divide by 2. So the median is 8.5. Okay. So when you have an even number of observations, when you have odd number of observations, it's gonna be different to calculate the median. Okay. So if it's odd, then just pick the middle one. If it's even, then you pick 2 and divide by 2. Okay. That's the median. And the third one is a mode. Okay, mode. Mode is in Korean 최빈값. 최빈값. It's not the name of the person. 최빈값. So it's the value that occurs most frequently. Okay, that occurs most frequently. Actually, mode is very popular word in Korea these days, right? You guys used, I'm not sure, it's maybe a little bit outdated, but people say, oh, I'm in 시험 공부 mode. I'm in some mode, right? Like some kind of those kind of words. But here, in the statistics, mode is like, basically, actually that makes sense. You are in 시험 공부 mode. That means you are, among all those times, you are using the most of time for 시험 공부, right? So mode is like this. So mode, basically, the most frequently occurred value is the mode. Okay. But the data may have more than one mode, right? For example, like if data has a 0, 0, 1, 1, 2, 2, then there are 3 modes. 0 is mode, 1 is mode, 2 is the mode, right? So there could be a 2 mode, 3 mode, 3 mode, 4 mode, and so on. Okay. And mode is useful for mainly describing nominal data, like qualitative data. This is qualitative data. For example, if you have data about the marital status, okay, and then you have like 30 people and 15 people, 30 people and 10 people are married and 10 people are single, 5 people are divorced and 5 people are widowed. Then there are 2 modes, single and married. Okay, so mode is useful to describing qualitative data. Okay, so in this example, in the first black point, 0, 7, 12, 5, 14, 8, 0, 9, 22, 33, 10 observations. There are one number that appears the most often. That is number 0. Right? 0 appears twice. So the mode of this data set or this data is 0. Right? And 0 is not in the middle, actually. It's not in the central location of the distribution, right? But still, 0 is the mode. Okay? So in that sense, mode may not be a very good measure for central location. Okay? That is the mode. If a distribution means basically how those numbers in your sample or numbers in the population, for example, like heights are distributed from the lowest number to the largest number. If a distribution is symmetric, then the mean, median, and mode may coincide. Symmetric is 대칭, right? 대칭. Symmetric is like this. Like some distribution is like this, like bell-shaped. And there is middle point. And this middle point is a median, mean, and mode. Mode is definitely the point that is most frequently occurs. So that is here. Median means what? Median means the left part of the area and the right part of the area has the same area, then that point is the median. Okay? And mean has different ways of calculation in this kind of case, which we will learn in the later chapters. But in this kind of symmetric distribution, mean and median and mode are the same. Almost always mean and median are the same if the distribution is symmetric, but mode is not necessarily the same as mean and median. For example, you can think about the distribution. It's like this. like this. There are the middle point here. Mean and median are the same. Okay, and this point is mean and median, but mode is here and there, right? There are different modes, and modes are not necessarily same as mean and median, even though the distribution is symmetric, like that. Right? So mean and median coincide, but mode, in this case coincide, this case does not coincide with mean and mode, also mean and median. Okay, mode are not necessarily coincide. Okay, questions before we move on? Okay, let's move on. If a distribution is asymmetric, okay, 비대칭, say skewed to the left or skewed to the right. Skewed means like distribution is like this, then skewed to the right. There are right tail, like long right tail, is skewed, right? Then the mean and median and mode, they all could be different. For example, like this type of graph. By the way, if you look at this type of graph, this y-axis, the height, is the frequency, relative frequency or frequency. And x is basically the values the variable can take. Okay, this is frequency here. Y-axis is the frequency or relative frequency or probability. You can think about later. Relative frequency here, and this value is basically the value of x, the variable. Then mode is definitely the one that the number that is most frequently occurs. So this value is the mode. This value is the mode. And median, again, median gives the left part of the area, right? This area, and the right part of the area. This area must be the same. Then that point, this point, is the median. Okay. So median. You can think about the number case 0, 0, 1, 1, 2, 2, but we pick the middle one, right? Then pick the middle one means one. Exactly the half is in here, and exactly the other half is there. So that is the definition of probability. A mean is somewhere which is actually a little bit harder to calculate, but it's this kind of skew distribution, mean, median, mode, could be different. Okay. We will learn how to calculate median in this kind of distribution. Actually, in order to calculate the mean for this kind of distribution, we need to use integration. I think in our course we will not do any integration. 적분 배웠나요, 여러분? In high school, have you guys learned 적분 or in college? But we are not gonna use any integral 적분 in this course. Okay. Which one is the best? Mean, median, mode. As you can see, definitely mode is not the best. How about mean and median? Which one is best? Mean is generally our selection. If you have a lot of data, right, sample size big, then even though there is one or two outliers, their effect will be very small because your denominator, you're dividing by a very large number, small n. Your sample size is big, then outlier doesn't matter. Then mean is still okay. But your sample is small. You have only like 5 people, and then there is one outlier by chance. Then mean is not the best choice. In that kind of case, median may be better. Okay, so it depends on actually sample size. These days, data are big, very big. Data are very big. You have like a million. Million is actually even small number these days. These days, what, for example, my PhD student is working on has like 100 million observations easily, and then just one outlier doesn't matter. So in those kind of case, mean is actually quite good measure for central locations. Mode is not median, if you have many outliers, many extreme values, or your data sample size is small, then median may be the best. Okay. To see why median is better than mean in some cases, let's look at this data again, 0, 7, 12, up to 33. Okay, 10 individuals. And then if we change this 33 to 133, okay, 33 to 133, then if you calculate the mean is 21, okay? And there are only two numbers, 22 and 133 are above the mean, making this statistics quite, out of the central location, right? So it's a poor measure of central location. But median stays the same. Median is the same. Even though you change one number to the outlier, still median is the same. Okay? In this kind of small sample case, maybe median is the best one. Let's try to do some example. Okay? So there are a number of sick days due to cold and flu last year was recorded by a sample of 15 students. Okay? So number of sick days due to cold and flu last year, this is basically the variable. Right? This is the variable, number of sick days due to cold and flu last year. I will call this as X, okay, variable X. And there are 15 adults of the sample, right? Sample of 15 adults. So N is 15, small N is 15. And the data, for example, this is X1, X2, X15, right? And you are asked to calculate the mean, median, and mode. Of course, the calculation is very easy, but let me give you 3 minutes to solve these questions. Okay. So please calculate the mean, median, and mode. Okay, let's go over this. So very simple calculation, right? What I want to emphasize here is whenever we have this kind of question, but today is very simple, right? Topic 2, topic 3, very simple. But later topics is gonna be quite complicated. Could be quite complicated. And as I have done, we kind of try to transform this kind of English word into math or statistics framework, so that we define variable and we give this information into mathematical notation, and then we need to find the mean, median, and mode. And this is basically the sample, so we have to calculate the sample mean, right? Sample mean, sample median, and sample mode. The sample mean is x bar, small x bar, which is 1 over n summation xi, right? And which is 5 plus 7 plus da 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 plus 12 divided by 15, so it's gonna be 6, okay? And then I hope you guys have this kind of exercise, doing this kind of exercise every day, like to try to use, don't forget to just putting this kind of thing. Not just, okay, just calculating mean, I know this calculating mean, and just adding those numbers and divide by the number of observations. Okay, that's good. That's definitely correct. But for the later chapters, we have to prepare to use this kind of mathematical definitions. Okay. So x mid, so I will just denote this median as x mid. So median, in order to get the median, we have to sort these values from the lowest to the largest. So 0, 0, 2, 3, 3, 5, 5, 5, 6, 7, 8, 9, 10, 12, 15. So there are 7 numbers here, and there are another 7 numbers there, and the middle one is 5. Okay, so median is 5. Mode is the number that is most frequently appear in the data, so that is 5, right? 5 appears 3 times, so mode is 5. Median is 5, mean is 6 in this case. Easy, right? Questions? Comments? Problems? Okay, let's move on to measures of variability. So far, what we have talked about is the measures of central location. As I mentioned earlier, if you think about the people's height as a variable, then this variable has many different values. Small, such as like 100 centimeters maybe. Large as 최홍만, like 200, like 30 centimeters or something like that. Huge variation. So if you only know the central location of the variable, then basically you are losing lots of information, right? So we need to know something more. So that is the measures of variability. Okay, we have to tell many different stories about this distribution of a variable or the data. So if you look at, for example, those two curves. So first one is the blue, which is highly concentrated on the number 15, and they are actually the distribution of the class scores. So one grade's distribution is very concentrated on number 50, and the other distribution is also concentrated on 50 but has more variability, right? Variability, right? The red one has more variation, more relatively more evenly distributed, right? So these two classes definitely have different types of students scores, right? So in order to know how they are different, we have to calculate some measures of variability. So the first thing is very simple one. Very simple one. This one is the range. Range is a 범위, right? 범위. Range is the simplest measure of variability, calculated as the maximum minus minimum. So largest value of observation minus smallest value of the observations. So if you have two sets of data, first set of data 4, 4, 4, 4, 50, and range is 50 minus 4, so that is 46, right? This is the maximum 50, minimum 4, So you got 46, right? And then there is another set of data 4, 8, 15, 24, 39, 50. Range is again the same. The largest value 50 minus the lowest value 4, so 46. Again the same. So range is one that is very easy to calculate, but give very little information. Except you may calculate who is the tallest person, maybe Hasungjin, 230, and then shortest person, I don't know, maybe the one baby has maybe 2 centimeters long. But that it doesn't give any information about Korean people's height distribution, right? So this is easy to calculate, but have very small meanings, right? So then, more important measure of variability is variance, and there is variance and its related measure, standard deviation. And some people may think this is the most important statistics. I think Keller textbook may say variance is the most important statistic, but I don't agree with Keller. The most important statistics definitely mean. Mean is definitely the most important statistic. Who cares variance more than the mean? Of course, maybe if you go to finance sector, then variance may be more important than mean. But still, for many people, mean is the most important value of the statistic, most important statistic. Anyway, population variance is denoted by sigma square. Okay, this is a sigma. This is sigma. Right? Sigma and squared. Okay, sigma squared. And sigma squared is calculated as a summation of what? Summation of xi, each value that a person or the unit can takes, minus the population mean, and we take a square. So many different values of the heights, and then that height, each height minus the average height, and you take a square distance between these two numbers, and you sum them up and divide by capital N. Again, this mu is population mean, unknown. We don't know population mean. Okay, and population size, we don't know. We don't know how many people are in Korea, right? So this number sigma square is unknown. Unknown population parameter that we want to estimate later. How can we estimate this? Of course, we draw a sample, okay, and have a similar size of the observations, n number of observations. With this x1 to small xn, we calculate this s square, okay, s square, which is summation of xi minus. Now we subtract a sample mean. Instead of population mean, we subtract the sample mean and we take a square. Again, the square distance. And then we add them up and divide by n minus 1. There are interesting features here. We subtract sample mean instead of population mean, and we subtract 1 from the sample size n. Okay? That is the interesting feature of the sample standard deviation. Why we divide by n minus 1 instead of small n is because of this guy x bar. Okay? This x bar. This x bar is the problem. This x bar is something that replaces this unknown value mu. Actually, in order to calculate the sample standard deviation, the ideal way is, okay, we subtract population mean and take a square and add them up, this distance, and we divide by n. And this is the ideal way of calculating sample standard deviation, if we know population mean. But we don't know population mean, so we replace this guy with x bar. And you can just think about this x bar as a one observation. And we are losing one observation by replacing population mean. That's why we lose 1. Okay? That's why we divide by n minus 1 instead of n. Okay? And later, maybe in topic 8 or topic 7, we will learn the concept of unbiasedness. Unbiased or bias. Or bias. The concept of bias. Bias is 편의. It's not a 편의점. 편의. 편의 means what? 편의 means so if you take an expectation of this guy, basically what we want is if we take an expectation, later we will learn expectation. Take an expectation of this guy, then we want to have that guy, sigma squared. Then this guy will be a good guess. But if you have n instead of n minus 1, if you take expectation of this guy, then that's not going to be sigma squared. Only the case we have n minus divided by n minus 1, this guy's expectation will be same as sigma squared. That's why we need to divide by n minus 1. There are two basic reasons that actually are coinciding. So we lose freedom because we have to estimate this mu with x bar. So that's why we lose one observation. And then we divide by n minus 1. That is actually the way we get the unbiased estimate. If you wouldn't mind, let me explain this in Korean. 한번만 Korean 할까요? 한번만 한국말로. 여기서 원래는 뭐든지 샘플 베리언스 구할 때는 그 값, 샘플이 갖는 값을 평균, 파퓰레이션 평균, 우리가 모르는 파퓰레이션 평균으로 빼서 제곱한 다음에 더해서 n으로 나눠주면 가장 좋은데 파퓰레이션 평균을 모르니까 뭔가로 얘를 대체해야 돼요. 대체할 때 x1으로 대체해도 되고 x2로 대체해도 되고 뭐로 대체해도 되는데 평균이랑 가장 비슷한 값이 뭐냐? x바잖아요. 샘플민으로 대체해주면서 하나를 잃어버리는 거죠. 하나를 우리가 써버렸기 때문에 n-1으로 나눠줘야 됩니다. 얘는 결국은 우리가 가지고 있는 This guy is a combination of xi's. This guy is a combination of xi's. So we are basically losing one linear combination of x1 to xn, right? So that's why we are losing one information, so one freedom. So that's why we use s square, which is divided by n minus 1. Okay. Again, this sigma is s in Greek letters. Okay, sigma is Greek letters s. So that's why we use sigma. And sigma is not s is not the variance. Variance is v, right? But this is for standard deviation. Standard deviation is s, right? The first English word character is s. So that's why people use s for standard deviation, and s square is the variance. So sigma is standard deviation, and sigma square is the variance. Let's move on. Let's try to calculate the mean and variance with this sample values 17, 15, 23, 7, 9, 13. So this following sample consists of number of jobs students apply for. So the x is the number of jobs students applied for, and then there are 6 students, n equals to 6, right? x1 is 17, x2 is 15, x6 is 13. Let's try to calculate the mean and variance. Let me give you another 3 minutes to solve this question, and then after that I will solve this question for you guys. Okay, let's solve this question. So again, this is the about the sample, right? Following sample consists of the number of jobs. 6 students apply 4, so we need to calculate sample mean and sample variance, right? Sample mean is x bar 1 over n summation I equals 1 to n xi. So 17 plus 15 plus da 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 plus 13 divided by 6 is 14. So it's a elementary school math. And then s square, a little bit complicated but still easy. But again, please keep this kind of definition first. So formula s square is summation I equals 1 to n xi minus x bar square divided by n minus 1. So 17 minus 14 square plus 15 minus 14 square plus da 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 13 minus 14 square divided by 6 minus 1, right? 6 minus 1, which is equal to 33.2. When I was teaching at Cornell as a teaching assistant, actually quite many students makes a mistake in this s square calculation, like divide by n instead of n minus 1. So whenever you are in the exam under time pressure, people could make mistake. Instead of n minus 1, people divide this by n. And we haven't learned sample standard deviation, but sample standard deviation is simply just a square root of sample variance. So sample standard deviation S is square root of S square, which is square root of 33.2. So we get 5.76. That is sample standard deviation. Okay. So next slide is explaining the sample standard deviation. So sample standard deviation or standard deviation is simply the square root of the variance. So population standard deviation is sigma, which is square root of sigma square, and sample standard deviation is S, is a square root of S square. Okay? So that's why people use S to denote this this measure, right? Any questions? I think this is a good place to stop. So let me stop here today, and next week we will talk about this topic and the rest of the topic.